The Alien Equation by Dr. Grace and Little Kayla. So today we're going to talk about the alien equation. Well, not this alien equation, this alien equation, or more commonly called Drake's equation. Drake's equation, formulated by Frank Drake in the 1960s, allows us to ask, in a clever way, how many alien worlds exist in our galaxy. Before we begin, we'll start with a simpler example. If we say that little Kayla only likes soft, yellow toys, we can put together a simple formula that allows us to figure out how many toys can Kayla play with. So we'll say n equals the amount of toys that Kayla can play with. So we need to know first of all how many toys we have, what fraction of those are soft, because she only likes soft toys, and then what fraction of those soft toys are yellow. So again we write the number of toys n is equal to, well, let's say 8. We got 2 cars, a doll's house, a water gun, and 4 soft teddy bears. 8 toys altogether. Well, if half of them are soft, that means we're left with 4. If half of those 4 soft teddies are only yellow, well, that leaves us with 2. 2 toys for Kayla to play with. Drake's equation, or the alien equation, is formulated in a very similar way. N is how many alien worlds exist in our galaxy. R is how many new stars form each year. Fp is the fraction of those stars that have planets. Ne is the fraction of those planets that are like Earth and that can support life. Fl is the fraction of those that can develop life. Fi, the fraction that can develop intelligence. And the fraction of those that can develop technology. And L then is just how long these civilizations might last. We can think about it in pictures like this. So let's start again. N, again, is still the question we're trying to ask. How many alien worlds in our galaxy? Then the first number, R star, is a number we've known for quite some time. Well, it's at least in the billions, so we'll put it equal to 1 billion, to be modest. So, starting with n is equal to 1 billion, each time we multiply then by one of our fractions, we'll reduce that number. But since we're starting with such a big number, hopefully we're still left with a reasonable number at the end. The first fraction then, Fp, the number of stars that have planets around them, until very recently we hadn't a clue what that number was, so people had to make guesses, and, well, conservative guesses went at about 1 over 10. But more recently, since 1995 when the first planet was discovered around a star, and since then we've discovered over 3,000 candidate planets, we now know that almost all stars have planets in orbit. And therefore we can put Fp to something more like 9 over 10. Or greater in fact. So plugging 9 over 10 into our formula brings it from 1 billion to about 900 million. Ne, the next fraction, then tells us what fraction of those 900 million planets are Earth-like. And again, like before, until recently we could only make estimates, and conservative estimates came in at about 1%, or 1 in 100. But just like before, we now know that that estimate was way too low. And since we've started discovering Earth-like planets, we've now discovered over a dozen, we know that it's in fact more like 1 in 5, or 20%. So plugging 1 in 5 into our formula leaves us with about 18 million. Unfortunately though, that's the end of the road in terms of our knowledge at the moment. We don't know Fl, Fi, Fe, or indeed Big L. But like before, we can start to make conservative estimates and plug those numbers in. So we can set Fl is equal to 1 over 100, even though, just like before, it's probably way too low and the numbers are probably a bit more optimistic. But putting it equal to 1 over 100 and plugging it into our formula brings us down to about 180,000. Again, Fi, setting it to 1 over 100, brings it to about 1,800. And finally then, for Fe, we'll set it again to 1 over 100, and that brings us down to a final of about 18. So we're down to 18 planets that could potentially support alien life just like ourselves, intelligent beings that are capable of communicating with us across space. 18 seems like a very low number, but considering that we've done as we have always done and set 3 of those fractions to 1 over 100, when in all reality they're probably much higher, meaning that our final total will probably be somewhat greater than 18. There's one symbol left then, L, that we haven't talked about, and we'll discuss that a little bit later. But for the moment, we leave it as an unknown. So let's recap and consider how we actually measure some of these symbols or fractions. So our star, we work this out by simply pointing our telescope to the skies and counting the number of stars we see. And we said before that this number was, well, probably tens or hundreds of billions, but we set it equal to 1 billion. FP, the fraction of stars with planets around them, before we set it to, well, first 1 over 100, but then we needed to correct that to 9 over 10. So almost all stars have planets. And this is evidenced by the fact that we've discovered over 3,400 planets since the first one we detected only in 1995. To recap on NE then, the fraction of those planets that are Earth-like, we said before that this is about 1 over 5, or 20%. So you might expect then that we should have detected some planets just like Earth already. And, in fact, we have. The names of these planets are listed below. Be careful though, those pictures are just artists' drawings from their imaginations of what they think the planets might actually look like. So far, our telescopes aren't sensitive enough to directly image any of these exoplanets. What is really cool though, is that we just found out that the star right next door to us, the closest star to Earth, Proxima Centauri, it too has an Earth-like exoplanet in orbit. The planet is called Proxima Centauri b, and planned future missions, such as the Project Starshot, will have the capability to directly image Proxima b as it zooms past it at 20% the speed of light. And with missions like Project Starshot, combined with the James Webb Space Telescope, due for launch next year, we'll finally be able to start figuring out the remaining three fractions FL, FI, and FE. Now, let's finally turn our attention to the remaining symbol in our formula, big L. The amount of time these alien civilizations might stick around for after they've developed technology. Unfortunately, we know from our own experience that with smart technology can often come dangerous weapons. So, we must ask the question that does smart technology equal aliens with dangerous weapons capable of destroying themselves? We know that on Earth, at least, the development of radio communications coincided with the development of dangerous nuclear weapons. So unfortunately, it may be the case that once aliens develop radio communications that would be capable of communicating with us here on Earth, they may also develop nuclear weapons and just go and destroy themselves, and therefore not stick around for very long, meaning L will be relatively low. This might go to explain why we haven't, so far, detected any alien signals through radio communications. We have been searching. SETI, the Search for Extraterrestrial Intelligence, has been searching for alien signals from the sky for decades now, and they've not detected anything. So, this may be the reason. Hopefully, though, there's a better reason. Maybe these aliens are so smart that they've surpassed the use of radio technology and moved on to something far more sophisticated that us primitive Earthlings simply aren't capable of detecting because our technology hasn't reached that level yet. This is what I would hope for. So then, what have we learned? We've learned to use Frank Drake's alien equation to try to figure out how many alien worlds might exist in our galaxy. Although it looked like a long, tricky equation in the beginning, we've shown that all we need to do is start with a number and then multiply that number by a range of fractions, maybe halves, quarters, and then see what final number we're left at the end, and that gives us an estimate of how many intelligent civilizations in our galaxy there might be. Our estimate was about 18, but remember, that was based on very modest estimates of the fractions that we don't know yet, FL, FI, and FE. We set them all to 1% or 1 in 100, when in all reality, history has shown us that these fractions are probably much, much larger. Even still, imagine the number was just 18. 18 smart, intelligent, alien civilizations communicating with us through space. All we need to do is point our radio dishes in the right direction and listen very closely. Who knows, maybe very soon we'll be able to report the discovery of the very first alien message sent to us through radio communications by a distant alien world.